So we're going to look at the hanging weight problem, but we're going to look at it in a slightly different way. And maybe it's going to help you realize what's going on. Again, hanging weight, 20 kips, 25 foot in length. This one we're going to do 1 1/8 inch diameter, and it's going to be a 36 steel. And the question is, what's the elongation? Now, we have an elongation formula, but we're not going to use that today. We're going to try to use our basic formulas. And the first one is stress is equal to the load divided by the area. The second one is the definition of strain, which is elongation divided by length. And the third one is the definition of the modulus of elasticity, capital E, is equal to stress divided by strain. Our three basic formulas. So the first step is we're going to see, what do we know? What do we know? We know the load. P is 20 kips. We know the length is 25 feet. And we're going to right away convert that to 300 inches. Multiply it times 12. We know the modulus of elasticity because we have A36 steel, and we can look it up that A36 steel has a modulus of elasticity of 29,000 KSI. Do we know anything else? We can find out the area. We know the diameter. We therefore can get the radius. So we can get the area of pi r squared, which is equal to 0.994 inches squared. So now we're going to look at our equations, and we're going to check off what we know. We know P, we know L, we know E, and we know A. So, looking at the first equation, we know P and A, we can go and find the stress. Second equation, we have two unknowns. Third equation, we have two unknowns. We have one unknown. We're in good shape. We're going to use equation 1 that says stress is equal to load divided by area. The load we know is 20 kips. The area is 0.994 inches squared. And we get a number of 20.12 KSI. And we know that that's sort of a good number because it's less than 22, and I know that the allowable stress and tension for A36 steel is 22 KSI, and so it won't fail. So let's just say now we have another known. We can go back to our basic equations, and we're going to click off on the stress. So if we know the modulus of elasticity and we know the stress, we can find the strain. And we're going to use equation 3. I'm going to take us back up here. And we're going to say the modulus of elasticity is equal to the stress divided by the strain. Modulus of elasticity is 29,000 KSI. The stress is 22 KSI. And we're going to find this strain. We're going to look at units. We know that strain is unitless, so we're in pretty good shape, and we're going to get the strain of 0.0007, no units. Now we're going to look at, once again, we know the strain. Now we're going to say equation 2, I can get the elongation is what I was looking for in the first place. So the definition of strain is elongation divided by length. 0.0007 is equal to the elongation divided by 300 inches. Units, I'm pretty good shape. This is going to be inches. This is unitless, and we get a elongation of 0.02081. And I'm not going to show this because it's too many decimals. We only need hundredths of an inch, and we get elongation of 0.21 inches. I'm going to check for reasonableness. 20,000 pounds, that's a lot of weight. 1 inch rod, that's a lot of rod. 25 feet, that's a lot of feet. And 2/10, almost a quarter of an inch, so that's a big movement. So that sort of feels right to me. So this is another way of doing this problem. If you can't remember the big formula for elongation, the alternate method for elongation.